Hi guys, Mike here. Today I'd like to talk about, had a request from a friend, to talk about what's going on with the 9XA board and basically walk you through this entire board. Now I've made a few changes, one of which is, you'll see this board over here, which is basically, and if you notice carefully, I wish I could zoom in, your 555 is here. Now this is your primary capacitor, where you'd have it here on the board. But instead of that, I've made a set of jumpers. These are header pins, and you can put jumpers on them to engage or enable that particular capacitor. So you have a greater depth of more frequency range, whether it's a larger capacitor or a smaller capacitor, or you can select more than one capacitor to go a combination, so that you get any frequency range that you want. That's what that board's about. Now the other board here is quite a few different circuits in one. Take a different angle here. First of all, we have, let me come on over here, is this, which you might have seen on Max Miller's R&D Max forum. This is the, let me read that off there, 9XA board Addendum. Basically what I'm doing is taking a couple of MOSFETs and creating the gated pulse train that Stan is talking about, instead of having a single 9XA board with just one oscillator. This gives you the pulse, the gated pulse train. Like here, you have the pulse and gate. The problem with the 9XB board is, in my opinion, it was meant for Stan Meyer to cover all of his bases with regards to his patents, so that he could have make sure that nobody was able to say, okay, well, how about just the one board by itself, or one oscillator. So he's trying. That's what I figured he was doing. But the other things we have here is, if you look back here, looks at the camera. Here's the two little tiny MOSFETs and the two resistors. There's the 9XB A Addendum. Now also over here, excuse me, we have a Max called it a totem pole MOSFET driver. Now this is where I originally got it from, and I'll show you a link to this. I don't know how well you can see this, but this is where the signal comes in. I don't know how close I can get, but here you have your signal coming in. Now with I got this from a guy named Valyan PZ, and I'll send a link to this particular image, and hopefully you guys get a chance to look at his other videos, because this guy's got a lot going on, and he's got a lot to show. Learned quite a bit from him. Now one of the other things, after your signal comes through, you have quite a bit of amplification. When you put your excuse me, a little phlegmy this morning. If you put your probe right here on this point here, which is your output, let me turn that channel on, turn that one off, turn on, okay. And this right here, way out of resolution here. Hang on a second. Okay, bring her down. Take two. Okay. We're at the output of this output MOSFET. Now, if you get a chance here to look, and I have to hold it on so that you can see it, we're at 1 volt per division. That's just about 2 volts, which is not much when you consider what you're getting out. Now, we'll go back over here, and here we have 5 volts per division, and about 13 volts, which is your amplification. I need to get that steady. Go down. slow down. Okay. But what I'm trying to get at is it gives you a little bit more amplification for your when you send it off to the MOSFET to drive your circuit. Also have a inverter, which in his situation he didn't need it because his signal was basically upside down. If you do it according to the way this setup is, you'll need an inverter, which is basically just 10K resistor into your N-channel or NPN, and then a 4.7K to VCC, and then out to your MOSFET. That'll get your in the pulse up instead of pulse down. So that'll get that straightened out. So it's basically like an amplification instead of your, I forget what they call it, where you have your incoming sine wave is vertical, but it comes out as a negative. So that's what that is. And basically that's it. Now also here on the board we have just a 12 volt regulator back here, a couple of caps for smoothing. Now I pulled this power, if you'll notice this wire here comes off the bottom of the board, and I just tied that to the positive of the rectifier so that I could bring 12 volts into here instead of 5, which would get you a little bit more power output. Now if you were to, let me turn this on here, turn this guy off, 1 second. Okay, turn that back on. Okay, now if you take your signal off of the opto-isolator, it may be a little bit rough. It may not look very clean. But if you come off of here, there it is there. It's fairly clean. I don't understand why it has a little blips. But there's your other signal. This is your gate. I think the other on top of that gate are the somehow interference from the primary oscillator, kind of like inductive something interference. But if you were to come off of the output of the opto-isolator, unless you're driving with enough voltage, I think you're going to have a problem. That's why I don't go through there. I just bring my output from here off of these two at the switches, which is, let's see if I can show it to you easier. See, if you notice, here's your two sets of switches, and if you'll count these, this is actually 6 switches instead of 5. I happen to have these laying around, so I use these instead of having to buy additional switches. So, and then back to this diagram where you've got your two sets of switches, and you come off of here to tie into your primary frequency, which comes in through the drain, and then your gate frequency, which is the B side, comes into the gate, and then the rest of it is driven as your output. So that's basically it. I don't recommend using the opto-isolator optocoupler output. I tried using it, it just doesn't seem to work, but this does seem to work pretty good for me, so give it a try if you have any questions. I will be posting a link to this image here, and take a look at Val Yan PZ, his work. He's done a lot of good stuff. And if you have any questions, send me a note, or as they say, comment below. And don't forget to like. Oh yeah, you gotta have a like. Gotta get likes. A lot of likes. And I forgot. I even totally forgot. This is where you make your adjustments for your frequency. Here you have your main frequency, and this is set up so that as you turn this in this direction, your frequency would be lower, because the wave tends to be spread out. as you increase it in this direction, your wave tends to look like that. That's why they're kind of set that way. And then this one is in likes the other way, whereas as you go in that direction, your gate spreads out, and the other way. That's basically it. Here's your power MOSFET that would be going out to your cell, or no, actually, this is for the to the primary. It would feed the primary, and that's basically it. If you have any questions, send me a message. This is Mike. I'm out of here. Bye.